Hi there, in this video I'm going to make the crank webs for this little Hoglet V-twin engine. So the crank webs are made out of a couple of pieces of mild steel bar, and I got this bar 1 metre long from a company, an eBay seller called Steel2Go. The actual company is B.E. Jenkins Limited in Grantham, and 1 metre long piece of this, which was 50mm wide by 12mm thick, was only £21.50 including delivery, which I thought was a bargain. I ordered it on the Monday and it arrived on the Tuesday, so you can't go wrong with that. But anyway, for the crank webs, this dimension here should be 2 inches now. The fact that I've got 50mm, it means, and I've tidied these up, means that I've actually got 1.94 here, but I think we'll be okay. The thickness I've reduced down to 7/16 of an inch, and the width is 3.126 of an inch. So what I need to do first of all, I think, is to centre the piece on the milling machine and drill and ream a 3/8 of an inch hole there. Once I've done that, I'm then going to move down here 1/4 of an inch and drill and ream another 3/8 of an inch hole. Once I've done that, I think I'm going to try and centre back on this hole here on the rotary table and then mill these radiuses here. Having done that, I'm then going to try and cut these out. And once that machining's been completed, there's a requirement to cut a slot in here and drill and tap a hole for a bolt to go through. So that's the plan, and I think what I'm going to do is to keep life simple, or simpler maybe, is I'm going to super glue these together, I think. And once I've drilled and reamed the hole through there, I think I'll bolt them together. So that's the plan. So far so good. Now to take these corners off and put a radius on, I think I'm going to try and use the lathe. So to do that I've just made this mandrel. So I can put that through there. Nice tight fit. Bolt it on and then bolt the other hole up to stop any movement. And then I can put that on the collet chuck in the lathe. This is going to take a while. Well, I've been turning at 200 RPM and cutting in 10th hour increments, and it's taken forever. And these interrupted cuts are quite heavy on the cutter. So this is my last cut now. So I'm going to cut 5th hour off. I've put a new cutter in, and hopefully it'll turn out okay. Happy with that. Well, in hindsight, I think I'd have been better off machining these half circles before putting the sort of radius on the sides. That way I could have held it in the chuck a lot easier. I mean, I can do that one holding it in the chuck, but for these two I've had to resort to this collet chuck, but it feels pretty solid. I put a bit of round stock in there first of all, and use a coaxial indicator to centre on it, and just as a double check, that looks pretty spot on to me. So I'll reposition the table and start drilling this semicircle. I think the radius on this is 1/2 inch. Well, for the purposes of the camera, I'll have a go at machining this one first of all, and this is an ER40 collet chuck holding this 1 inch diameter cutter. I suppose another option would be to use a boarding head. You never know, I might have to resort to that, but we'll see how I get on. Don't like that. Try locking the column, see if that helps. Okay, so I've had a bit of a rethink. So I've moved the table that way, and I'm going to start nibbling away using this 1 inch diameter cutter. Well, this seems to be working, so I'll continue cutting downwards, and once I've completed that cut, I move the table back out again, do another cut, and then gradually move it to the original position. So that's the plan. So I'll get back to you once I'm a bit closer to finishing. Well, that was sort of going okay, but then the part moved very slightly and the spindle locked. So I'm going to have to rethink how I hold this part. Okay, so this is plan B, and I could kick myself for not doing these before turning these sides, but anyway, you live and learn. So I've got the vise all nice and square, nicely bolted down, got some parallels in here. I've rested the part on the parallels. I've got a little mini jack here which is supporting this end, and I'm clamping this end down as well. So everything feels nice and rock solid, and I'm cutting at about 40 thou at a time, sort of on the y-axis, and it seems to be going okay. So I'll continue like this until I've done both these sides, and then I'll get back to you. So now to machine this half circle, and this is a 3/4 of an inch 2 flute end mill, and I'm going to cut in 40 thou increments until I get to half of the diameter. Well, that's not looking too bad. Now the drawing suggests drilling and tapping 14 by 28 UNF for some bolts to go through, but I'm going to use M6 bolts. So my plan will be to first of all drill right through with a 5mm drill bit, so that's in each of these. Then M6 clear, so 6.1mm to a depth of 1/2 inch, taking me down to that point roughly. Then I need the head clearance, so that's 10mm to a depth of 7mm there. And then lastly I just need to tap the lower bit to M6 thread, so it can take bolts like that. And they're drilled in the centre position there on each of these pieces. Okay, so I've positioned the x-axis on this centre line here. Then I found the centre of the two pieces and moved the y-axis that way, 0.22 of an inch and centre drilled, and then moved it this way another 0.22 of an inch, 0.44 of an inch to drill the other hole, or to centre drill. So this is just basic drilling and tapping, so I'll do most of it off camera. Well, they seem to turn out okay. Pretty close to the edges, but I got away with it. So all I need to do now is to cut some slots in here. Not too sure how to do that. Well, I think it might be my lucky day. I've just found a metal cutting saw for my old jigsaw. I'll have to give that a try. Blimey. Well, I've just roughly cut a piece of silver steel, which is about 4/10 of a thou over 3/8 of an inch, and you need to tighten these really tight, but it seems to have got it. So fingers crossed it will work in real life. Don't look bad actually. Well, some of you might recall that when I made the cam housing in my last video, I struggled to find any oil light bushes. But I've had a bit more of a search around the internet, and I found a couple of companies that do them in the UK, Simply Bearings and Bearing Boys. And I've actually bought one from Simply Bearings for the front, and works a treat. I'm really happy with it. And I've also made this timing cover as well. Now, in terms of the crank webs, I suppose I'm yet to be convinced that this method is going to work. But I think if I use silver steel that's oversized slightly, I might get away with it. But my next problem I've got is the actual flywheels, and I've been searching around for some bronze, and I can't really find any that's, you know, sort of a decent price. In fact, I'm struggling finding something that's a silly price. And I saw a posting, I think from Jason B, that he suggested that you can get bronze, cast bronze, in a sort of like tube format. And I've looked around for that as well. I just can't find any. And I found some in the States, and that's going to cost about between 150 and 200 quid, and there's no way I'm going to pay that. So I'm just wondering about alternatives. I think brass would be a similar sort of price, and I think it's a bit lighter. So what I'm thinking of is buying some cast iron sort of chuck adapter blanks, which you can get about 25 quid each. And if I machine those to size and finish them, give them a really nice polish up, like I've done on my other engines, that might be an alternative solution. They won't look as spectacular, but I think it'll be functional. But anyway, if anybody's any sort of thoughts on that, where I can get some decent bronze at a decent price, I'd really appreciate it. So anyway, I hope you liked the video, and I hope to see you later.